Okay, today quick look at mole to liter conversions, and this is the third and sort of last arm of the mole conversions we've been looking at. So taking a look at some things here. The mole map right here, we've been kind of talking about this a little bit. We've already looked at two of the pieces, but then this piece right here, that's kind of where we're going to be looking at today. So you'll notice that it's got moles and it's got volume. It's got 22.4 and it has STP. So first of all, STP. STP just stands for standard temperature and pressure. So standard temperature and pressure. And so we can see that right here. There's STP, standard temperature and pressure. So what is that? Standard temperature is either 0 Celsius or 273 Kelvin, and standard pressure is 1 atm or 760 millimeters of mercury. Now, what are we going to do with that information? Well, basically, what that is telling you is that if you have a problem that's at standard temperature and pressure, STP, then you can use 22.4. So 22.4 is basically how many liters are in a mole at standard temperature and pressure. So for our purposes, if you see standard temperature and pressure, STP, that's a big clue that you should be using 22.4. So we're going to be looking at standard temperature and pressure, but mostly we're just going to be looking at liter conversions, and we will use 22.4. Now, if it's a little bit warmer or a little bit cooler, pressure is different, then the constant would not be 22.4. So let's slide down here to some examples, because these are really very easy. We kind of saved the easiest conversion for the end. So it says how many moles are in 14.1 liters of ammonia. So same way to solve any of these problems, you're going to find the number, you're going to find the unit, and that's where you're going to start. So we're going to write 14.1. So we'll go 14.1, and we'll put a liter here, and this is going to be ammonia. And then we would go ahead and do a conversion factor. No different than we've been doing previously, and we put liters on the bottom. And we put moles on top because it wants us to go to moles. Moles are going to always get the 1. And now here's the new thing. Liters are going to get 22.4. Now, point out just something that in this particular problem, it did not say STP, but we're just going to basically assume it's at STP. Probably be better if it said at STP at the back of the problem, but that's not that big of a deal. So liters are going to cancel, take 14.1 and divide it by 22.4. And you'll get the answer. And I'm going to give you the answers here in a minute. I'm going to set the second one up real quick. The same trick. We're going to go with our starting value, always 5.00. That is a mole, and that is neon. And we're going to go ahead and do a conversion factor. We're going to get rid of the mole. See, it doesn't change. We have a unit here. So it's going to go right to the bottom. Mole is going to still get a value of a 1. And then we're going to be looking for liters, and so 22.4. So again, probably better if this said at STP, but again, we're going to assume that so we can use the 22.4. All right, so first one is a division problem. So 14.1 divided by 22.4. Hit enter. Second one is multiplication. 5 times 22.4. So remember, if the value is on top, we're going to be multiplying by that value. If the value is on bottom, we're going to divide by that value. So let's slide down here and look at the answer. So there it is, all set up, nice and neat. You can see that we've got 14.1 divided by 22.4 division problem, and there's your answer, 0.629. And last one there, 5.00 times 22.4, and there you go. All right, a couple more examples here. So if you want to pause the video here and just give it a quick attempt, you can see how you can do. So hopefully you paused it and took an opportunity there. I'm going to go ahead and write these out for you. So hopefully you started by writing down 16.0 liters of krypton, and you went ahead and did a conversion factor, liters on the bottom, moles on top. And again, I think that I need to go back and fix this in the notes, but this should say STP. That would be better. And then same with this one. But that's not going to really change much. It would just be better than giving you information. So 0.25 moles of argon. And let's go ahead and get rid of the moles. And there you go. And again, you can see that we're just either multiplying or dividing by 22.4. So this top one we're going to divide, and this bottom one we're going to multiply. So let's take a look at how that looks. And there you go. There's your answers. 16 divided by 22.4 and 0.25 multiplied by 22.4. And here's a couple of two-step problems where you're integrating not only the liters, but now we're integrating in a multi-step problem. So remember, a multi-step problem, if they don't talk about moles in the problem, it's a two-step problem. And so this one is talking about grams and liters, so two-step. And this one's talking about liters and atoms. So again, two steps. So let's go ahead and set these up so you can see a couple of two-step problems real quick. And let's go ahead and we're going to go 5.0 liters of neon. And here's my conversion factor. So I'm going to get rid of the liters and I'm going to go into the mole. So you always have to have the mole on the top or the bottom. We're going to go 22.4. Now again, problem would be better if I said at STP in the prompt. And so then here, we're going to get rid of those moles. And we're going to go into grams. And so then we just look up neon. So you just look up neon on your periodic table, and you guys can do that. Just find neon, and it's going to be 20.18. And we'll put that right there. And that's how we'd solve that. So we'd have liters going away and moles going away. So how would you run this through a calculator? It would be 5 divided by 22.4, because that's on the bottom, and then multiplied by 20.8. And then the last one here, going to be a bit bigger, so we're going to go 3.01 times 10 to the 23rd atoms. I'm going to save a little space here, and that's xenon. So first conversion factor, we're going to have to get rid of atoms. Okay, so again, it doesn't say moles anywhere, so it's a two-step conversion factor. So atoms are going to go to the bottom. So that's going to be 6.02 times 10 to the 23rd atoms on the bottom, and then 1 mole on top, because if you need mole either on top or bottom. And then let's go ahead and get rid of that mole. And we want liters, so we're going to go 22.4. And then there you go. All right, so check your units. Atoms are canceling, that's good. Moles are canceling, that's good. We're left with liters, which is kind of what we want. So the way you're going to run it through your calculator, you're going to take 3.01 times 10 to the 23rd. Divided by 6.02 times 10 to the 23rd. Now be careful, make sure you're using that exponential key. So when you're doing these exponents, you're looking for a double E key or an EXP key or a times 10 to the x key. So that's how we're going to plug that in our calculator. So do all that, and then you take 3.01 times 10 to the 23rd divided by 6.02 times 10 to the 23rd multiplied by 22.4. And there we go. There are the answers. And so you can kind of see I've got that there, 4.5 and 11.2. And if you want to try a couple more on your own, I've got these right here, got the answers for you. You can kind of look at how I'm working through it. But again, it's just sort of the same thing over and over. This one has grams, and we're going to liters. It doesn't talk about the moles, so it's a two-step. This one, asking for liters, and you have molecules again, two-step. So hopefully that helps you out. We're going to do some practice. I think as a kind of a general statement that liters are really the easiest of the conversions. And so again, a lot of the problems here really should say at STP, but for our purposes, we're going to use that 22.4. So, all right, hopefully this helped you out. And of course, you can ask me any questions on these conversions.